Hello everyone, I am Assistant Professor Urmi Shah from IT/ICT Department of LJ Institute of Engineering and Technology. We will be starting with chapter number 9, that is spread spectrum communication, in today's session. So basically up till now we have done the introduction of spread spectrum communication module. In that we have covered the different types of spread spectrum techniques, that is FHSS and DSSS. Now basically what is FHSS? That is frequency hopping spread spectrum. And what is DSSS? That is direct sequence spread spectrum. All these things we have discussed in the previous session. In the upcoming session, we will be looking forward with some advanced communication techniques which are widely used in market and industry. So let's start with the session. In this session, we are going to cover following topics. So these are the topics to be covered in today's session. That is CDMA technique, spread spectrum technique, and the types of spread spectrum. So let's move forward. So firstly, in the last session I told you that we will be moving forward with the advanced kind of technique, that is code division multiple access technique. Basically, multiplexing technique is used with spread spectrum whenever we have starting of data with digital data rate D. Basically here we are performing multiplexing of signals. At a time multiple signals are processed in form of code and then they have been transmitted from one place to another place using the CDMA technique. Here the start will be from data signal rate T and it will be called bit data rate. The breakage will be in form of each bit into k chips according to fixed pattern which will be in specific order given to each user. Here the user's code will be allotted to some specific bit code. Here the new channel has chip data KD chips per second where k can be anything integer value. It is 6 for example. So 3 users communicating with base receiver R will have the 6 code values. Code for A, B and C will be in form of 6 data signals. So this is how the code division multiple access technique preferred whenever we are using this multiplexing technique in market or industry. So basically CDMA is the best example, or you can see over here the best example for CDMA is whenever I am having 3 users and the message encoded is in form of 1101. So user 1 will be allotted 1101. The next user will be allotted the another sequence. Third user will be allotted the another sequence. So this way multiple data or multiple signal can be processed at a time using the code division multiple access technique. Nextly, the example here depicts that considering A communicating with the base knows A's code. So A's code is already revealed. Assuming these assumptions, if the communication is in synchronization and A wants to send a data 1, then send chip pattern will be 1 minus 1 minus 1 1 minus 1 1. So this is basically the sending chip pattern for A. It is a code for A. Now if A wants to send the code 0, then it will send the chip pattern as minus 1 1 1 minus 1 1 minus 1. Exactly inversion of the data when it was sending 1. So this way the complement of A's code will be performed whenever the A code wants to send the reverse data which was sending 1. So for sending in 0, we will perform the complement of A's code. The decoder ignores other sources whenever we are using A's code to decode, and the orthogonal codes are one of the best examples for these CDMA explanation. CDMA for DSSS, that is code division multiple access technique for direct sequence spread spectrum. Here, n number of users, each having different orthogonal pseudo-noise sequence, and the modulation for each user will perform having the data stream generated using BPSK modulation scheme, that is binary phase shift scheme. Here then, the sequence which is generated, which will be multiplied by the spreading code of the user. So this is actually CDMA when I am using the DSS spectrum. For direct spread spectrum environment, the CDMA data stream generated will be directly multiplied with the spreading code of the DSS scheme. So as you can see over here, the environment created for DSSS technique using CDMA, here the input will be multiplied or mixed up with the DSSS spreading code. It will be further processed with a mixer which is having the mixing of the spreader code, and finally the output will be generated at every stage of CDMA. Mixing will be performed. So these are the example of 7-channel CDMA encoding and decoding. As you can see over here, multiple signals have been multiplexed and they are being encoded, and then finally at the receiver they will be decoded. So here this is an example of 7-channel CDMA. 7 different signals are transmitted each from all the channels, and finally the encoding and decoding process has been done in CDMA technique, that is code division multiple access. Now let's understand the word spread spectrum. In 2 to 3 sessions I have been repeatedly telling you what is spread spectrum, and these are the different kinds of spread spectrum. But actually what does this spread spectrum means and why we are doing it? Usually the spectrum of a signal is related to the data rate. Data rate is your symbol rate. How many symbols or how many data bits can be transmitted in a single interval, that is your symbol rate. The null to null bandwidth can be represented as 1 by t. T is your total time duration or symbol duration in which one symbol can be transmitted. So that is actually your symbol rate. So your spectrum of signal will be represented in form of symbol rate or your data rate. How much data can be transmitted in t time duration. Now, what does spread spectrum means? Normal spectrum, everyone has heard, but spread spectrum is wider spectrum compared to 1 by t. Because here we are performing the spreading of signal. The code signal has been represented in form of spreaded code. So the spreading is achieved using the spreading signal, which is also called as code signal or spreading code. So here the receiver uses correlation or match filtering to recover the original data. So this is spread spectrum. Now what are the different types of spread spectrum? The different types of spread spectrum which we have already discussed is DSSS and FHSS. In direct sequence spread spectrum, each information symbol is chipped into a pattern of smaller symbols. The pattern is also called as spread spectrum code or sequence. It is used for the IEEE standard 802.11, CDMA 2000, WCDMA and IS 95 standards. So these are the applications where this DSSS technique is widely preferred. Coming to the another kind of technique, that is FHSS, Frequency Hopping Spread Spectrum. Here the symbols or packets are transmitted on different frequency carriers each time. Slow frequency hopping, the same frequency carrier is used over several symbols or a packet. Fast frequency hopping, the frequency carrier is changed within a symbol period. Here it is used in GSM, IEEE 80, 2.11, the legacy has been continued, and in Bluetooth technology as well. So these are the applications and what are the different technique DSSS and FHSS is all about. Nextly, systems using spread spectrum. So what are the market application, industry application where this spread spectrum communication technique has been used? So the first is DSSS is employed in 2G CDMA system where it is used in IS-95 and CDMA 2000 standard. DSSS is employed in all 3G cellular systems where it is using UMTS and HSPA. DSSS was used in legacy IEEE 802.11, that is our Wi-Fi technology. So basically this is the diagram for DSSS modulation scheme, and your data bits have been inputted in form of data input which will be multiplied with the spreading coding input, and further it will process the spread bits. So the original data stream is chipped up into a pattern of pulses for a smaller duration, and that pulses are processed using the spreaded bits. Good correlation properties, good cross correlation properties with other patterns. Each pattern is called spread spectrum code or spread spectrum sequence. So this is all about DSSS modulation. In DSSS detailing, instead of transmitting a rectangular pulse for a 0 or 1, we transmit a sequence of narrower rectangular pulses. The narrow pulses are called chips, and you often see references to chips per second instead of bits per second. The easiest way of creating a DSSS signal is to multiply one period of the spreading sequence with each data symbol. The example over here is barcode signal, which is used in IEEE 802.11 standard, having barcode sequence as 111, minus 1, minus 1, minus 1, 1, minus 1, minus 1, 1, minus 1. To transmit a 0, you need to send 1, 1, 1, minus 1, minus 1, minus 1, 1, minus 1, minus 1, 1, minus 1. And exactly opposite. If I want to transmit a 1, I need to send minus 1, minus 1, 1, 1, 1, minus 1, 1, 1, minus 1, 1. So sometimes parts of the spreading sequence are multiplied with the data symbol. So this is all about DSSS. Now talking about the definition of processing gain. What is actually processing gain? The duration of a chip is usually represented by TC. So this is your chip duration. And the duration of the bit is represented by T. So T by TC ratio will give you N, which is called the processing gain of your DSS system. The processing gain is also the ratio between the bandwidth of the spread signal to the bandwidth of the data signal. The T time, which is your duration of bit time, divided by your chip time will give you N, that is your processing gain. In many cases, this is also the ratio of height of the autocorrelation peak to the maximum side lobe. And this ratio depends on the spreading code properties. So this is how the processing code or processing gain is generated. This is the operation. which is performed at the SS transceiver. As you can see how the transmitter and receiver blocks are generated, so demodulation here involves a process that is known as correlation. Correlation properties and autocorrelation processes are involved whenever we are performing DSSS. So here, this autocorrelation properties of Barker sequence we will be discussing in the upcoming next session. What is this M sequence, how it is generated using autocorrelation process, this all things I will be discussing in the upcoming next session. Following are the references for the topics which I have covered today. You can refer these books for reading the topics which we have seen today, and also in the next session I will be starting with the autocorrelation properties for sending these chip sequences, and we will be learning more about another kind of spread spectrum communication properties and how they are widely used. So thank you so much for watching this session. In the upcoming session, we will be moving forward with chapter number 9, that is spread spectrum communication. Thank you for watching this session.